Hello and welcome to. We're going to have a look at vector cross product in this episode. I don't know what I'm going to call it. I might call it a another episode, or I might call it a special name. I don't know. Yeah. So what's going on with the vector cross product? Well, if we look at vector cross product, it is this one. What it does basically is, the way it works is basically if you take the first vector, you take uh, it multiplies two vectors in such a way that it basically does the right hand rule on it. The right hand rule is something used in angular momentum. Basically, what you do is you would do to get the z answer. So, say you had a vector x, y, z, and then you had a second vector x, y, z. What you would do is to get the z answer, you would do xy minus yx. It's anti-commutative, so yeah. So you would do that. What was it? I think it was x, y. Yeah, it's x, y minus yx, and then for the y vector, you would do. So for the z, that would be like I said, x, y minus yx. For the if you wanted to work out the y vector, that would be zx. So you would imagine the x, y, z forms looped. So yeah, and then so there would be zx, and then you would subtract from that. Yeah, it'd be zx, and then subtract xz from that. So yeah. So you would take the basically what I'm trying to say is you take the whatever comes first. So yeah, so zx, and then you just subtract xz. So basically, because xz is not the yeah. So yeah, because xz is not in the loop. So x y z x y z. Imagine that it loops now. That's the reason why you're going to be subtracting xz, because xz is not in that thing at all. And then for the x vector, it would be yz minus, and then yz minus zy. So yeah, that's basically how the vector cross product works. Um, so yeah, so let's see in action then. So let's have a look at the axial look first of all. And we'll take the axial look of the caster. And yeah, let's have a look, see what it is. Let's just see what it is first of all. Just want to try and get the oops, let's get rid of that. So we'll look at the axial look first of all. So I'm just going to do axial look and vector cross product, I think. Yeah. So we'll stick this one in there. So let's have a look at the axial look. So here we have on this side, this is the x-axis here, going positive. This is the z-axis. So you can see that's 1, 0, 0. So it doesn't matter. So you see, so that's 1, 0, 0. Then you can imagine if we turn right, we're going 0, 0, 1. Which incidentally is the vector transpose of this. This is why the vector transpose is what it is. You can see it's basically the right hand turn. This whole thing, if you put your it's basically the direction which is completely orthogonal. I was thinking about it before, like see what happens when I look down there. Doesn't matter how I look down. As long as I look down beyond a certain point. But basically, the way you have to look at it, here's one axis going up. So you can imagine the axis going from the origin directly up, and then from the origin directly to x equals infinity. Yeah? And then the way to look at it in a way is it's interesting to look at it. I was thinking of like trying to think of like some kind of visualization for it. I was thinking of a wheelbarrow. You have the wheelbarrow with a huge rock in it, and you're trying to get the rock out of the wheelbarrow. But the problem is you're standing on a glass floor, and below the glass floor is, say, spikes. So how are you gonna tip that wheelbarrow to get it out? And that's going to be the direction, which is basically orthogonal to everything. So basically, you want to get as far away from this axis and this axis. So if you think about it, how are you going to get far away from there? Right? How are you going to get far away? The answer is you need to get. So I mean, first of all, you need to work out which plane which plane are you going to even be on? Right. I mean, why not go? You know, why not go like this way, for instance? I mean, that doesn't seem right. Maybe this way then is better. But the problem is, if we start going this way, you see, what we're going to do is we're going to go this diagonal. And what's the length of this diagonal? Well, the length of this diagonal is root 2, isn't it? Is the yeah, basically, because we're going to have this length is 1. This length is 1, so it's 1 squared plus 1 squared. Yeah, yeah, so it's basically root 2. Is it right 2? Yeah. It's not going to be 4, is it? I think it's root 2. So I'm pretty sure the length is 1.4. I can't remember at this point. But yeah, so basically you don't want to go diagonal, yeah? Is what I'm trying to say there. And then, so you don't want to go diagonal. So you can't go this way. So basically, the way you're going to get away from these, you're basically trying to go to a direction which is getting away from the this direction and getting away from this direction. And the answer, of course, is going to be in this direction. But here's a plane. So it's really along this whole line is where you want to go. I mean, it's an interesting thing where how to. But yeah, you can see that goes. So basically, yeah. So we've got positive x, we've got positive z, we've got negative x, and we've got negative z over here. So let's do the vector transpose and see if anything particular happens. So like I say, the vector transpose. I actually explained it right at the beginning, but you do have to pay attention to what I said at the beginning because it's not. It's not necessarily. If you put it this way, if you're going to want to try and get the blocks in exactly the place you want them, it's not going to work unless you pay attention to what I said at the beginning. Basically, you just have to try and remember that fact. But this, I would imagine, takes the absolute value of it. Is there? And the absolute value. So the absolute value of -3 is 3, for instance. And there's different raycasts as well. So yeah, so so say we want to take the so we want to take the cross product, yeah, and we want to take it of the axial look, and we want the other figure. And one thing I will point out here is that you see, for instance, when I do this, the trick debug, this thing runs like this. It goes like this. And that definitely affects things. So you've got to be careful about that. Yeah. So what are the parameters for this going to be? Well, you see, I don't want that like that. You see, I want the... It's a problematic because unfortunately the construct is going to take up 3 spots, and unfortunately they're quite useful spots. We'll see. Anyway. If we want to debug it, it's going to be a bit awkward. You see, I want the debug. I guess I want the debug of this fact. Yeah, I'll just put the debugs down here. So yeah, so we're going to want 1. So yeah, so basically you can put anything in here, but if you just use the vector cross product rule, but like I say, it's a little bit wordy in a way. But I feel like it's not that difficult. It will just take a little while to get that one. Okay, so I think this should be enough. We've got a debug here. Okay, so what they should do. So yeah, we get a look vector. So for instance, when I'm looking straight down there at the x-axis, straight down to the x-axis 1, 0, 0, and then it will multiply it by this 0, 1, 0, and that should get the third vector. And also, you make the point is right. The point is, if you know the magnitude, for instance, if you know that the magnitude of this vector is going to be 5 blocks, which you could get potentially from a raycast, and you know, say you know 12, say you know 12 blocks. I'm trying to work out which length you'd actually be able to get, because you can definitely do Pythagorean triples, but I'm not quite sure exactly how to get there yet. I'll work it out. I don't think I'm very far away. But this is like the hardest thing in the whole mod. So as long as you can get this. Well, I mean, it is kind of the hardest thing. Honestly, the loop thing is pretty harder, but well, I don't know. So let's have a look at the results of this, shall we? So there we go. Now we can see the vector transpose, right? So the first result is where we're looking, and the sorry, the cross product. So so this is where we're looking, and we're saying, well, we take 1, 0, 0. Cross with 0 1 0, and that results in 0 0 1. Just think about it. Just think about what we're doing there on the z-axis, right? We're doing xy minus yx. Okay, we're placing this vector first. Remember, we're placing this 1 0 0 first, and then we're multiplying, we're cross product with the 0 1 0 vector. So what that means is we're going to take 1 0 0. So we take 1 0 0 first vector, 0 1 0 second vector. So what's the calculation? We do 1 times 1. So that's going to be 1 from that 1 is from the first vector, the x coordinate in the first vector, and that other one is the y coordinate. So we do that. So we're going to do So you can see how that works, right? 1 times 1, so it's x, so that's going to be 1. And then what we're going to do is we're going to subtract yx. So what's the y value there? So it's 0 times 0. So it's going to be 1 times 1 minus 0 times 0 to find the z value, yeah? And then, yeah, I could go to rack, maybe I will actually. So if we want to find the y value, again, we'd have to do xz minus, so we do zx, because we need to focus, because the first thing, it's anti-commutative, so the first number has to be in the sequence, and it can wrap around xyz, xyz. So it would be zx, so what's that going to be? It's going to be the 0 from the first vector, that z value from the first vector, and times the x from the 0 1 vector. So what's that? It's going to be 0 times 0, which is 0. Okay. So then we want to do, but then we need to subtract the xz value. Yeah. So the x value will be 0. Will be 1. So 1 from this vector. Yeah. So we're subtracting xz. So it's going to be 1 times 0 is 0. And that's going to be 0. Yeah. Yeah. So just wait. Let me just do that again. Zx minus xz. I'm just trying to get it. 0 times 0 is minus. Then we do xz minus 1 time. That's right. And then we do minus 1 xz minus 1 times 0, which is 0. Yeah. And then for the x coordinate, we would need to do yz minus zy. Yeah, so for the x coordinate, we do yz, so that would be 0 from that. The z is a 0. 0 times 0 is 0. Minus and then minus, so the z coordinate here is 0. The y coordinate in this one is 1. So yeah, 1 0 0. Yeah, it's a bit, but yeah, as you can see, the right hand rule will always take precedence here. Yeah, so 1 0 0 0 0 1, and then you can work out. You can see how the right hand rule works. See 0 0 1. So when we turn, when we do it on this, the cross product, right? We're going to be negating in the x direction, right? And then you see that takes on the value of the of our next sort of turn here, and then we'll be negating in the z direction, for instance. Yeah. And then here we're going to be negating in the x direction. So you can see how that kind of works. It's interesting. This is actually quite a big turn, I think, about it. So that goes minus 1 0 0. This is the direction we're looking at. So that means we're looking towards negative x. And the cross product will be the negative z over here. And we're looking in the negative z over here. So the cross product of negative z in the negative z direction is going to be the positive x direction. And then the cross product of positive x is the z. The cross product of positive z is the negative x. Cross product of negative x is, yeah. So you can see how that works anyway. So that's a pretty interesting thing anyway. I mean, that is basically how the cross product works. Yeah, I mean, I don't know. There's a couple of raycasts. The Axis raycast. It's a localized raycast side. But yeah, I think that's probably going to do with the explanation of the of some of that stuff of the cross product. So I'll see. I'll come back in another video.